In this module, we shall learn about phototherapy. We shall cover the principles of phototherapy, factors influencing the efficiency of phototherapy, guidelines for phototherapy, different types of phototherapy units and their maintenance. In addition, we shall also discuss the care during phototherapy and the complications. Phototherapy reduces total serum bilirubin by three proposed mechanisms. First, configurational isomerization, where native bilirubin is converted to water-soluble geometric isomers that are excreted in the bile. But this process is reversible, where these geometric isomers are reverted to native isomers. Second, by converting bilirubin to lumirubin by structural change isomerization. This process is irreversible. Lumirubin is excreted through bile and urine. Third mechanism is photooxidation, where colorless products are produced, excreted in the bile and urine. This process is very slow. For term babies and babies born after 35 weeks of gestation, the American Academy of Pediatrics guidelines can be followed. There are three lines in this chart. The upper line is for the healthy babies born after 38 weeks of gestation. The middle line is for the healthy babies born between 35 and 37 completed weeks of gestation, and also followed for the sick and babies with risk factors born after 38 weeks of gestation. The risk factors include isoimmune hemolytic disease, G6PD deficiency, significant lethargy, temperature instability, sepsis, acidosis or hypoalbuminemia if albumin is measured, which is defined as an albumin less than 3 grams per deciliter. The lower line is followed for the sick and babies with risk factors as mentioned in the chart born between 35 and 37 completed weeks of gestation. The therapeutic efficacy of phototherapy is dependent on the following factors: the spectral qualities of the delivered light, that is the wavelength range and peak, the intensity of light, that is the irradiance, exposed body surface area, skin thickness and pigmentation, the total bilirubin at clinical presentation, the etiology of jaundice and the duration of exposure. The higher the TSB level at presentation, more rapid is the decline in TSB. Phototherapy is likely to be less effective if jaundice is due to hemolysis. Pigmented skin has been reported to impede the effectiveness of phototherapy. We shall discuss about the spectral quality of light, intensity of light, that is irradiance, and the exposed body surface area a little more in detail. The irradiance, in addition, is dependent on the distance between the baby and the lights. The relationship is related to the inverse square law, that is, the intensity of light decreases with the square of the distance. So, to increase the irradiance, the phototherapy unit should be placed as close as possible. Minimum distance is at least 15 cm from the bassinet to observe the baby. An important point to be remembered is that the temperature of the baby should be noted regularly every 2 to 3 hourly when phototherapy units are placed closely. Studies suggest that application of slings or white curtains hanging from the unit or reflectors resulted in increase in irradiance marginally. One study suggested significantly rapid decline in TSB level at 4 hours and had significantly decreased duration of phototherapy as compared to conventional phototherapy without the slings or white curtains. While applying slings, ensure that heat vents and fans are not covered, otherwise there can be a fire hazard. Effective phototherapy is very much dependent on the exposed body surface area. The greater the area exposed, the greater the fall of total bilirubin. With the present overhead and underneath devices used singly, only up to 30% of the body surface area is exposed to light. In term newborns with significant hyperbilirubinemia, studies suggested that double phototherapy provided rapid and more effective bilirubin reduction than conventional phototherapy alone due to higher spectral irradiance and greater body surface area exposed. Irradiance is a critical determinant of effectiveness of phototherapy. Phototherapy should be started with such a light source that can provide an irradiance of at least 6 to 8 microwatt per square centimeter per nanometer in the 425 to 475 nanometer range. Intensive phototherapy is defined as the use of blue light in the range of 425 to 475 nanometer band delivered at 30 microwatt per square centimeter per nanometer or higher to the greatest body surface area as possible. What if the bilirubin is not falling? It could be a problem with the unit or with the baby. The unit may not work or may have low irradiance or not enough body surface area of the infant is covered. The baby may have underlying hemolytic state which may lead to increasing bilirubin levels or G6PD deficiency or dehydration or inadequate stooling. Understanding these problems will help us in better management of our infants. Two types of phototherapy devices are currently available: the conventional phototherapy devices and the fiber-optic phototherapy devices. Conventional phototherapy devices typically use one or more tungsten halogen bulb, long or compact or folded fluorescent lamps, or most recently light-emitting diodes. Fiber-optic devices, also called Billy blanket, use a standard light source like a quartz halogen or a high-intensity light-emitting diode bulb. Fluorescent tubes are the most common light source used. Several phototherapy devices use this light source. These tubes have the advantage of being inexpensive, but their irradiance reduces with time. The most commonly used light source is a special blue tube such as F20T12BB or TL5220 watt Philips, which provide more irradiance in the blue spectrum than other tubes. Cool white light has also been used together with special blue tubes, as pure blue light is poorly tolerated by the caregiver and it can mask cyanosis in a sick infant. Position the phototherapy unit over the infant to obtain the desired irradiance of 10 to 40 microwatt per square centimeter per nanometer. The distance of the light from the infant has a significant effect on the intensity of phototherapy, and to achieve maximal intensity, the light should be positioned as close as possible to the infant. Fluorescent tubes may be brought within 10 cm of term infants without causing overheating. If increased irradiance is required, as already mentioned, add a second unit or use double surface or place a fiber optic pad under the infant. We shall discuss about the other important points to be taken care of in the subsequent slides. Advantages of this conventional system are: it can provide very high irradiance as much as 30 microwatt per centimeter square per nanometer at a distance of 35 centimeters from the source. Wavelengths used are in the range of 400 to 550 nanometer with a peak at 450 nanometer. A lamp usually runs for 1000 hours before the intensity of the light drops with usage. The bulb used in this conventional system is Philips PLL18W52. LED phototherapy unit utilizes high-intensity gallium nitride light-emitting diodes. Advantages over conventional phototherapy are that these devices are capable of delivering high spectral irradiance levels of more than 200 microwatt per square centimeter per nanometer within a very narrow emission spectrum in the blue range of 460 to 485 nanometer. This kind of unit does not emit light in the infrared range that reduces the potential risk of fluid loss, and these can be applied closer to the infant. Expected shelf life of the LEDs is about 10,000 to 50,000 hours that decreases the running cost. Electrical energy is converted to light energy more efficiently in LEDs than standard light devices, and thus greater efficiency is possible. Hence, they also produce less heat. In addition, since they have very low power consumption, they can be used in peripheral health setup. Moreover, LEDs project light toward the target. In vitro and in vivo experimentations have established that the efficacy of this light source is a match for the most intense halogen or fluorescent tubes. In fiber optic devices, the ultraviolet filtered light from a tungsten halogen bulb enters a fiber optic cable and is emitted from the sides and the end of the fiber optic fibers inside a plastic pad. The pad emits insignificant amounts of heat, so it can be placed in direct contact with the infant to deliver up to 35 microwatt per square centimeter per nanometer of spectral irradiance, mainly in the blue-green range. They have the option to increase their irradiance to a higher level. The orientation of the fiber optic fibers would determine the uniformity of emission. The main advantages of this system are that while receiving phototherapy, the infant can be held or even nursed, thereby minimizing infant-parent separation, and covering of the infant's eyes is not necessary. The main disadvantage is that the fiber optic devices cover a relatively small surface area and therefore is less efficient compared to overhead sources. These devices can be used as an adjunct to conventional overhead application of phototherapy, providing double phototherapy, thereby more closely approximating circumferential phototherapy, which is greater efficacy because of greater body surface area exposed to light. This slide shows us the infant placed over a fiber optic phototherapy device. Fiber optic phototherapy can be used as the sole source of phototherapy or as an adjunct to conventional treatment. Insert panel into disposable cover so that it is flat and is directed towards the infant. Phototherapy pad is placed around the infant's back directly. Discard disposable cover after each application and when it is soiled. Connect the fiber optic panel to illuminator. Allow the lamp to cool for 10 to 20 minutes before moving the illuminator. Let us now discuss about the life of these lamps. If irradiance meter is available, then periodically measure the irradiance, and when irradiance has fallen to 2/3 of its original value or below 10 to 12 microwatt per square centimeter per nanometer, we might require a change of bulbs. So it is important to perform periodic checks of phototherapy units to make sure that an adequate irradiance is being delivered. Also, note that irradiance meter is designed to measure specific light source for the precise bandwidth. However, if the irradiance meter is not available, fluorescent long tubes should be changed every 1200 hours or 6 months of intermittent use, whichever is earlier, or when fluorescent lamps flicker or tube ends blacken. CFL lamps last 2000 to 3000 hours, while LED bulbs last for 10,000 to 50,000 hours. The total duration of usage of the lamps can be ensured either from the inbuilt timer installed in the unit or using the sticker on the unit to measure the date of replacement of the lamps. An equipment logbook can also be maintained in the unit for the above said purpose. The phototherapy unit should be cleaned at least weekly and before use for each baby. Visible stains should be cleaned with moist cloth soaked in mild detergent solution. The solutions used for disinfection are 6% hydrogen peroxide or 2% glutaraldehyde or freshly prepared 0.5% sodium hypochlorite solution. It is to be remembered that there should be no spillage of fluids inside the unit while cleaning the unit. Disconnect the phototherapy unit from the main power input and allow the unit to cool before attempting cleaning in order to avoid the possibility of burns. Soak the cloth sparingly with the cleaning solution mentioned by the manufacturer or the unit's own protocol just to moisten the cloth. Excessive cleaning solution may spill inside the unit and damage the electrical and electronic circuits inside. The reflector inside the unit must remain dust-free. The company person should be contacted if cleaning of the reflector is not feasible by the user. Let us now learn some important points which need to be considered while handling a phototherapy unit. Do not keep the phototherapy unit under the radiant warmer. Do not use water or any other liquid to clean the electrical or electronic parts. Do not keep any liquid on top of the machine. Do not cover the fan or vents with curtain or blanket. These are meant for cooling the unit. If these are blocked, then temperature will increase inside the unit that will decrease the life of lamps and may cause a fire. Let us now understand some common problems and the remedial measures which may be undertaken to resolve them. If lamps do not illuminate, check the following and correct step by step. First, check the main power input. If it is okay, then check whether the main cable is plugged in properly to the main power supply socket. If not, then plug in properly. Despite this, if the unit is still not working, check the main power cable. If it is damaged, replace it. The unit is still not working, then check the on-off switch. If not on, then switch it to on. If it is still not working, check the fuse and replace it if required. If the unit is not working after so many checks, contact the company person. If lamps are blinking, again check the following and correct step by step. First, check the total duration of usage of lamps from the unit using the inbuilt timer or the sticker on the unit mentioning the date of installation of the lamps or from the log register maintained in the ward for the said purpose. If the lamp has exceeded the total life hours mentioned by the company, replace the lamp. If the total duration of usage is not exceeded the total life hours, then check whether the ends of the lamps are black. If the ends are black, then replace the lamp. If the ends are not black, check the starter by replacing one after another. If still there is flickering, then contact the company person. For initiating phototherapy, the following steps must be followed. Undress the baby completely. Cover the gonads and the eyes. Monitor temperature every 2 to 3 hours. Record the weight daily. Continue breastfeeding as per schedule. Switch off the unit while the mother is breastfeeding. Discontinue phototherapy when the total serum bilirubin level returns to a safe level. Check for rebound rise within 24 hours after stopping phototherapy. Remember that eyes should be covered to prevent retinal damage by bright lights. Another important point to be emphasized is that adequate hydration and stooling has to be ensured while the infant is under phototherapy. Every intervention carries the risk of side effects, hence it is very important to timely detect and manage them. Photooxidation products may lead to loose motions. There might be increased fluid loss through skin secondary to excessive heat. So temperature should be monitored routinely. Exposure of cells to light intensity similar to those used in phototherapy can produce DNA strand breaks and mutations. Being a photosensitizer, bilirubin enhances the level of DNA damage. Shielding of gonads is indicated during phototherapy to prevent chromosomal damage. Exposure to phototherapy lights produces damage to the retina. Phototherapy increases skin blood flow through a mechanism known as photorelaxation, the pathway of which is believed to involve the production and action of nitric oxide on the vasculature of the skin. However, endogenous carbon monoxide production has also been associated with vasorelaxation. Bronze baby syndrome occurs in some infants with cholestatic jaundice who are exposed to phototherapy as a result of accumulation of porphyrins in the skin and serum. Separation of the mother from her baby and interference with bonding is also a problem. Let us now summarize what all we have learnt. Phototherapy is the commonest therapeutic intervention used for hyperbilirubinemia. Phototherapy decreases bilirubin by configurational and structural isomerization and photooxidation to non-toxic polar compounds that are excreted in bile and urine without conjugation. Blue-green light with wavelengths in the range of 425 to 475 nanometer is the most effective. One should ensure adequate irradiance and cover maximum body surface area, thus ensuring rapid decline of serum bilirubin. We are sure if we follow the above knowledge and apply these principles for treatment of jaundice, we shall be able to prevent bilirubin-induced neuropathic damage. Thank you